Hello friends, this video on 3-dimensional geometry part 1 is brought to you by examfear.com. No more fear from exam. What we will study? We will study introduction, direction, cosine and direction ratio of a line. We will study equation of a line in a space. We will study angle between two lines, shortest distance between two lines. We will also study planes. We will study coplanarity of two lines. We will study angle between two planes. We will study distance of a point from a plane. We will also study angle between a line and a plane. So let's go through the chapter of 3D. Let's study why we need 3D. If you see, this is a room, a normal room we have. You throw a ball, the ball goes, come back, and you see ball like this. Let's repeat. So you have a ball, ball goes, come back like this. The ball is following this path. So if you see in this, it's all three-dimensional. Ball went from here to here, here to here, and then it came back here. Correct? So this is a typical example of three-dimensional path. If you see the aeroplane, it is also three-dimensional because it has x, y, and z coordinates. In case of ball also, it had x, y, and z coordinates, right? It had x, y, and z coordinates. Similarly, in case of aeroplane also, it had x, y, and z coordinates. So when you talk about 3D, 3D has x, y, and z coordinates. So in this chapter, we will study more about three-dimensional geometry. So if you see here, the axis we use, the coordinates we use, coordinate plane we use to represent this is like this. So this is my coordinate plane. Correct? This is my coordinate plane. To represent this three-dimensional space, x, y, and z. This is x, this is y, and this is z. Please note, x, both are same actually. And if you want to represent a point, the point will be somewhere here or here or here. You want to represent some line, it will be something like this. So we'll study all these things, right? So we'll study three-dimensional, and to study three-dimensional, one thing that is mandatory is the coordinate system. So we'll use this three coordinate plane system. And if you see this three planes, the one in blue, the green, and red is x, y, and z plane, divides the whole thing into 8 equal halves. This is one part, this is another part, second part, third part, fourth part, fifth part, sixth part, seventh part, and eighth part is something which is hidden that side, right? So 8 equal halves it divides, and each of these are called octants. So let's start with the chapter now. Let's see how we represent a point in a Cartesian and vector form. So I have a point. This is my point P, let's suppose. Not a line, only a point. This is my point P. I want to represent this guy in Cartesian form. And let's suppose the value of x, y, z is here 5, 7, 8. Okay. So if my value of x, y, z at this point is 5, 7, 8. So in Cartesian form, how I represent this? I say x, y, z is equal to 5, 7, 8. This is how I represent this guy in Cartesian form. How I represent in vector form? So these things you already know. If you are not confident in this, please watch my previous chapter where I have introduced vectors and we have explained how to represent a point and lines in the vector form. So in this case, we will represent this point as 5i plus 7j plus 8k, right? Because this guy has a 5 units effect on x, right? 7 on y and 8 on z. So this is my Cartesian and vector form representation for a point. This is something which we know. Now let's talk about a line, 2D line. So if there's a 2D line and it's 2D, we are not talking about the z axis now, okay? So this is x, let's suppose this is y, and this is not there. So I'm talking about a 2D line here. So the points are, let's suppose 3, 5 and 2, 8. Please note it's a two-dimensional line, and we are very much confident in two-dimensional line questions, we know how to represent two-dimensional line. So if there's a line where my end coordinates are 3, 5 and 2, 8 in two-dimensional, and I have to represent this in Cartesian form. So Cartesian form is a normal form we use. So what we do, we form the equation of the line. We say y minus some coordinates y1 8 by x minus this coordinate 2 is equal to y2 minus y1, that is 8 minus 5, by x2 minus x1, that is 2 minus 3, and that is minus 3. Correct? So you solve this, you get y minus 8 is equal to minus 3 into x minus 2. So this is my Cartesian form representation of this line. Correct? If you want to represent this vector form, how we'll do? In vector form, we know we have, this is 2, this is 3, right? So we'll have, say, I component will be this guy. So let's see how it will be. So let's suppose this is my point A and this is point B, right? So let's suppose this is a point vector for A and this is point vector for B. So in this equation, if you see, vector A plus this guy vector AB is equal to vector B, or I say my vector AB is nothing but B vector minus A vector. So what is B vector? Is 2i plus 8j, correct? 2i 8j minus A vector 3i 5j, correct? So this is nothing but minus I plus 3j, and this is my vector representation for this 2D line. These things we already know. We already know how to represent a point in Cartesian and vector form. We also know how to represent a 2D line. So in this case, we are representing a 2D line. Correct? This is a 2D line in Cartesian and vector form. What we'll understand in this is how to represent a 3D line. So in this case, it has all x, y, z coordinates. This is 3y5, 3, 5, 1. Let's suppose this is 8, 7, 5. So this guy has all x, y and z coordinates, right? There are two lines. How to represent this line in Cartesian form and vector form? We don't know this. This is a little difficult. So let's study this. We don't know how to represent this in Cartesian form. We have never studied this. And we don't know how to represent this in vector form also, because we have never studied this. Correct? Vector form, I think we can still make a guess, because if this guy is A vector and this guy is B vector, let's suppose, this whole thing is AB vector, this will still apply the same formula. AB vector is my B vector minus A vector, and B vector is nothing but 8i 7j 5k, 8i 7j 5k, and this guy is 3i 5j 1k, 3i 5j 1k. So subtract this is 5i plus 2j plus 4. This is a vector representation. This is easy because we know how to find for 2D. Similar concept we can use for 3D, but finding the Cartesian form of the 3D equation is difficult. So we'll study all these things in the few slides. So the reason why I took the point and the 2D was to make you aware that till now we know how to represent a point in Cartesian vector form. We know how to represent a two-dimensional line in Cartesian vector form. Now we'll study how to represent a 3D line in Cartesian and vector form. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.